Hello, A2 Trig students. You have arrived at the unit of graphing rational equations. So many things to find, so little time. Let's do it. Okay, so let's start with this equation. X squared minus 3x over x squared minus 2x minus 3. Pretty much the first step in graphing rational equations is going to be to factor your numerator and denominator. If your factoring skills are rusty, go take a look at my factoring playlist. There are some great videos on there to help you. But assuming that your factoring is in good shape, when we look at this top equation, we have only two terms and no number terms. So we're going to start by factoring an x out of both terms, which leaves us with x times x minus 3. For this bottom one, maybe we're going to use the x method. If you don't know that method, go check out this video, but here we go. We've put our constant number there, we've put our coefficient of x there, and we're asking the question what multiplies to the top and adds to the bottom. We make our quick factor list. 1 and 3 are our only options, and now we assign the negative positive. We need to add to -2, which means we need our larger number to be negative, and then we do a quick check. -3 times 1, in fact, is -3. So that means that our bottom factors into x minus 3, x plus 1, that's taking each of these and putting them in there. All right, now we can see things a little more clearly, and we can start to find the things we need to graph our rational equation. The first thing we want to find are our vertical asymptotes. What's an asymptote? An asymptote is a line that your function will approach but never hit. What makes a vertical asymptote? Anything that makes your denominator equal 0. Because we know we can't have the denominator of a fraction equaling 0, so therefore we can approach that point on the graph, but we will not have a value at it. Okay, what makes each of these bottom factors equal 0? Well, I could set them equal to 0, or I could clever it and say, well, if I put a 3 in here, that would make this factor equal 0. So the line x equals 3 is one vertical asymptote, and then same thing here, if I put a -1 in, that makes that factor equal 0. So the line x equals -1 is also a vertical asymptote. Now, I'm just going to freehand this. You will probably have graph paper. But essentially, there's my dotted line asymptote through x equals 3 and my dotted line asymptote through x equals -1. Now, some of you may be shouting, no, 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 no. -3 is not an asymptote. Well, the next thing we would check for are holes. A hole occurs when I have the same factor on the top and the bottom. So what normally would be an asymptote actually is a hole. So we have no value at that point because it would in fact make the denominator 0, but because it's also on the top, it isn't an asymptote either. It's just a single point that has no value. So that means I'm going to erase the asymptote and I'm going to remove it from my vertical asymptote list, but instead note that I have a hole at 3, well, how do I find out the y value of my hole? If it's a hole, it has no value. Well, if we were to cancel this factor and then put 3 into what remains, that would give us 3 over 4. So the hole occurs at 3, 3/4. Okay, that's our vertical asymptote. That's our holes. Next up, we've got horizontal asymptotes. Horizontal asymptotes have 3 different cases. So we're going to take a look at what the case is here. And then later in the video, I'm going to talk to you about the other 2 cases. So stay tuned. Okay, but the first thing we want to check is the highest degree on the top and the highest degree on the bottom. So I'm going to go ahead and rewrite the equation as we first saw it, because that lets me more easily see my degree. To remind you, degree means the highest power you have when you've multiplied everything together. Okay, so don't look at it in this unmultiplied form. Look at it in your fully condensed form. So we have a squared on the top and a squared on the bottom. Okay, so that means we're in case 2, which is when the degree of the top, the highest degree of the top, is the same as the highest degree of the bottom. Then the horizontal asymptote occurs at the line y equals the coefficients of those two highest degree terms divided. The coefficient of this first term is 1, divided by the coefficient of this bottom term is 1. Our horizontal asymptote occurs at the line y equals 1. And so I'll go ahead and sketch that in too. Okay, now remember, there are two other cases. There's the case where the degree of the numerator is smaller than the degree of the denominator, and the case where the degree of the numerator is larger than the degree of the bottom. We're going to look at those at the end of the video. Stay tuned. Okay, next we want to look at intercepts. Okay, the x-intercept. Where does it intersect the x-axis? Well, that occurs when y is 0. So here's a fun little hack. If it occurs when y is 0, that means I would set my function equal to 0. And my first step is I would take the entire denominator and multiply both sides by it, which would eliminate it from the denominator. And this side would stay 0, because 0 times anything is 0. So the hack for how to find the x-intercept is just set your numerator equal to 0. So if my numerator equals 0, well, I know the two zeros of my numerator. It happens when it's 0, and that happens when it's 3. So it looks like I have two x-intercepts, except, again, this one doesn't count because we know at 3, we have a hole occurring at 3/4. All right, next, our y-intercept. So our y-intercept, when does it intersect the y-axis? Well, that occurs when x is 0. So that means if I throw 0 in for x, I get 0 in my numerator, and I get -3 in my denominator, but 0 divided by -3 is still 0. So my y-intercept in this case is the same as my x-intercept. Okay, the next thing I would want to do is I would make a t-chart and throw in a couple of numbers in this range so I can figure out, am I up here or am I down here? And then here I've already got a pretty good guess. I've got a point right here. So I am heading up toward that asymptote and down toward that asymptote. And then when I throw a couple numbers over here, so this is at -1, so maybe I want to throw -2 in. And when I throw -2 in, I find out my y value is 2, which puts me up there. And your teacher will probably want to see a couple more points, but I've got my asymptotes guiding me. So I know I'm heading up to, but never hitting that asymptote, and heading down, but never hitting that asymptote. And so that is my sketch of what that rational equation looks like. So this is a pretty good rough sketch. And the last thing we need to do, that pesky hole that keeps interfering with all the things, we need to remember to put an open circle in there. So we count over 1, 2, 3. And indeed, we're up at about 3/4. We're getting close to that one asymptote. And we're going to put a little hole there to indicate that we get infinitely close to a value at 3, and then we pick up again infinitely close to a value at 3, but on the other side of it and continue on. But actually at 3, we have no actual value. Okay, and then the last thing often that's asked for is the domain. And so don't forget that domain is everything x is allowed to be. So we know that it can be everything from -infinity to -1, soft parentheses, not including, and then everything from -1 to 3, soft parentheses, not including, and then everything from 3 on to +infinity. Similarly, the range is going to include -infinity up to 3/4, 3/4 to 1. Sorry, this is so messy. And then 1 to +infinity. So your domain is based on all of the asymptotes and x values of your hole, and your range is based on all of the asymptotes and y values of your hole. And that, my friends, is graphing rational equations. Now, let's talk about the other two horizontal asymptote cases. Okay, so let's look at this one. This is the same case we had. The highest degree on the top and the bottom is the same. That means the horizontal asymptote is the coefficients of that highest degree term. And so that would be a horizontal asymptote of 1/3. And let's talk for just a second. Let's geek out about why that's the case. Okay, as our variable gets larger and larger and larger, approaches infinity, right? This plus one here becomes utterly irrelevant. And because these guys are approaching infinity at the same rate, they will cancel each other out, leaving us with just the division of their coefficients. So that's why, as you approach infinity, that's how your horizontal asymptote gets created. Now, let's take a look at the other two cases. So here's the case where the degree of your numerator is smaller than the highest degree of your denominator. So again, let's apply the as we're approaching infinity case. Well, this plus one again becomes irrelevant, but the fact that our denominator is going to approach infinity way faster than our numerator means this whole fraction is getting smaller and smaller and smaller. And so in this case, your horizontal asymptote is going to be 0. It's not approaching negative infinity, it's approaching nothing when the denominator is so much larger than the numerator. And now let's take a look at the final case. So the level 1 understanding of the case where the degree of your numerator is larger than the degree of your denominator is that your fraction, your numerator, is getting bigger at a much faster pace than your denominator, which means you are approaching infinity, which means not applicable. You do not have that looks like Hana. You do not have a horizontal asymptote. Now, the real answer is you have a slant asymptote, but we're going to take a look at that on another video. Okay, my friends, that's your intro to graphing rational equations. Take a look at my factoring playlist if you need help with that. Go look at my channel. The very first videos I ever made were a 6-step series on graphing rational equations. So if you want to see my early attempts at video making and review graphing rational equations slower, go check those out. Leave any comments you have. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.